Okay guys, this is the last part about writing equations of sine and cosine that you guys will need to finish off all the different types of translations. So we've talked about vertical stretch or shrink or reflection with the A value, the amplitude. We talked about the K value, which is our vertical translation, up or down, which is exactly the way you see it. Remember that. And then we talked about H, which is our horizontal translation, left and right, or phase shift. So we're going to put all of those things together with the fact that we are going to have to worry about the period. And if I do remember correctly, if you talk about this using waves, that would be your frequency. How frequent is this wave repeating itself? So remember, we talked about in the first day that the period is how often it starts to repeat, or how far does it go before it repeats itself. So here's the thing, is that we should know, because we talked about at the very beginning, that standard period for sine and cosine is 360 degrees, one rotation of the unit circle, or 2 pi. So again, it does matter if you're in radians or if you're in degrees. Also, this part of the problem is tucked in with theta. So anything that's kind of packaged in with theta seems to do the opposite of what it looks like. So I have that stated on top there. So when you think you're multiplying theta by 2, you're actually taking the period and making it smaller by a half. When it's a 3, you're making the period 1/3 the size. Okay? So this is going to stretch the graph out. So if I had to draw a picture, a normal sine or cosine curve would look like this. But if I wanted to stretch it, I can make my coefficient smaller, and I might end up with something like this. It's more gradual, more elongated, taking the slinky and everybody's pulling one into the other, right? But then if I increase that coefficient number, and I'll show you where that coefficient goes in a second, if I increase it to a 3, a 4, a 5, a 6, a 7, 8, 9, 10, all of a sudden you're like, whoa, the period itself gets smaller. That means it goes from 2 pi and it shrinks down. It's going to happen in a shorter period of time, which means there's going to be more of them, and that will start to look like this. Okay? So it starts to squeeze together. You're letting the slinky come together. Okay? I think a slinky is a good visualization of stretching or shrinking a wave, because it kind of looks like a wave. Now, the question is, how do I know what the period is going to be given a formula, or the equation, or if I was given the graph, how can I find the number that needs to go into the equation? They're not exactly the same. They will change the other. They're indirectly related. They're not directly related. They're indirectly. You got direct variation, indirect variation. Inverse or indirect variation or inverse variation means as one goes up, one goes down. That's the situation we have here. So as we have here, we have period coefficient here in the middle, and this one's 4 degrees. It says that the period coefficient, the number that goes into the equation part, the number that most of the time, for now, because we're writing equations, we need that number. That number, if I'm in degrees, is you take 360 degrees, which is a normal period, and divide it by how many degrees does it take to start to repeat. So you start on top of a hill, or a bottom of a hill, or someplace. How many degrees would it take to get back to that exact same spot? You take those degrees, and then you divide it into 360, there's your number. So, on a graph, if it takes you from here to here, 360 degrees to get back to that same spot, what's your period coefficient? It's 360 divided by 360, which is 1. Okay, that's how you would find it. What happens if you're, again, testing from here to there, and you found out it's 180 degrees? Your period coefficient then, 360 divided by 180, which is 2. So 2 would be your number. Same thing over here if I'm talking about radians. Because obviously, sometimes we're in radians, sometimes we're in degrees. So I just divide it into 2 pi. So again, if it's from here to here is 2 pi, then it's 2 pi divided by 2 pi, which is 1. If it's pi, 2 pi divided by pi is 2. Ooh, let's change it here. Now, let's talk about what happens if I go from this one to this one, and I say, that is 4 pi. No, you're not dividing by 2 pi. Then, you are taking the 2 pi divided by 4 pi. What's your coefficient then? It's 1/2. So, you see how it's doing the opposite? The bigger the period is, the smaller the coefficient is. So where does it go in our equations? There's our next slide. It goes, guys, it goes in front of the variable. It goes in front of the variable. So if I had to draw this out, it would look like sine of bx or b theta. I used x in this one, or you could use theta. But it goes directly in front of the variable. Now, we're going to start chaining all 4 of these things together. And when we chain all 4 together, you're going to have a set of parentheses on there. Your coefficient, guys, will need to be out front of that parentheses. So at times, you also will see that. And what you're going to want to do is you're going to want to factor, because you can't find h unless b is completely off of it. So sometimes they're tricky. They multiply or distribute the b into the problem. They like to do that. And they give you bx plus bh. And so people are like, oh, BH is my left-right movement. No. You need to factor off that coefficient to be on its own so that H can be on its own. Okay? We'll get to that in some of our examples, and we'll show how that will be. So, what I got here is I tried to color code this, and I think I did. I'm going to pause the video so I can increase it. Okay, so I guess I can't increase it. But as you can see, the black sine curve starts at 0. Actually, all of them start at 0 and go up. So we know they're all sine. The black one is your normal. It takes, guys, if you look at your numbers, it's a little harder to see because they're going away, or they're a little smaller. But do you notice that from here all the way to here is 6.28. And 6.28, again, is how many pi? 2 pi. So that's 2 pi. So if I had to, I'll put a marker here, that's 2 pi. 6.28, 3.14 plus a 3.14, 6.28. So that would be just past 6, which is 2 pi. That is why, if you notice, it takes that long for this curve to go all the way up and down and restart. That means the period is 2 pi. And 2 pi, using the formula, divided into 2 pi, is 1. What's the number in front of x in this problem? 1. You don't necessarily need to write it, right? Now, looking at the red one. The red one looks like it's starting to scrunch up. So that means the period coefficient actually will be larger. Look at the red one. The red one has a higher frequency. That means that the period actually gets smaller. So why is it when I increase the number to a 4 for B, why does it seem like it's happening more often? More wavelengths, right? Guys, if I make the coefficient 4, it takes the period and divides it by 4. So the period's 1/4 the size. That means that instead of going 2 pi to start repeating, look what happens. It goes from here, up, down, and stops right there. So it's 1/4 the size. So wait a minute. Let's take a look at this. We said the period coefficient, so B is equal to 2 pi over the period. Right? That's the formula from the other page. Let's plug in the stuff we know. We're looking at the equation. If we're looking at the equation, you know what B is. What's B? 4. So 4 equals 2 pi over the period. We don't know the period. How can I find the period? Multiply by the period and divide by 4. So the period goes to the top, the 4 goes to the bottom. So we end up with the period equaling 2 pi over 4, which means what? Pi over 2. So every 90 degrees, you will have one full rotation. Wait a minute. What was pi over 2 in decimal form again?
30.
Yep. No. Pi over 2. We talked about that the very first day again. 1.57. Where does it start to repeat again? It goes from here, up, down to right there, which is 1.57. Guys, the whole entire rotation is happening quicker by a factor of 4. It's 4 times quicker. The frequency is increased by 4. Technically, watch this. This is kind of cool. Let's count. 1, 2, 3, 4 of them fit in the original period. Yeah.
No.
Yeah. Boom. Mind is blown. Now, guys, let's look at the orange one. The orange one has a period coefficient of 1/2. So if I do the same magic, thinking about what I did here, that coefficient got moved to the bottom, right? So it'd be 2 pi divided by that 1/2. When you divide by 1/2, you flip and
Multiply.
so what's 2 pi times 2?
4.
So that means it should go all the way from here to 4 pi, which makes it twice as big. So guys, your job is to find out how far in radians or degrees does the graph actually travel to repeat itself. So this is what you'll do. You'll look at the red graph, and you'll be like, okay, it starts here, and it goes to 1.57, which is pi over 2. Yeah?
Right.
So what we're going to do then is you would be like, okay, the B value is equal to, sorry, that should be a 2 pi over 2. I'm actually going to figure out how did I get the 4. Because that's what we need to find for our equations. So I'm going to look at the graph. I'm going to trace it and say, how long did it take to do that? 1.57. We keep on saying 1.57 is pi over 2. So I'm going to then take 2 pi, divide it by the new period, which is pi over 2. And when you do that, you flip and multiply. So it's 2 pi, or B equals 2 pi times 2 over pi, Pi's cancel. And you get 4. So 4 is why you get it there. So, you guys have all 4 pieces of information or ways to make it happen. You, first of all, order of operations here, guys. Find your center line. Find your amplitude. And then you either can mix these up. You can do phase shift, your left, right, H movement, or your period. It doesn't matter. The inside stuff won't change. None of it really changes, but I think by finding your center line first will make it easier to find your amplitude, and then you can decide on your period and your left-right movement. Of course, along with all of that, you want to decide, are you going to be calling it a sine curve or a cosine curve? Because again, that affects where your starting points are, if I'm looking for a high point or for the middle. And when you decide a sine or a cosine, if you have the option, it'll depend on how far you're moving it left or right, because you're going to be looking for those different places. So let's do an example like this one. Let's write the equation. If I'm looking at this, your first thought would be, I want to write it as a what? Sine or a cosine curve? Okay, I heard both, but which one do we really want to do?
Sine.
Cosine.
Why?
Why do I want to write it as cosine?
Going down.
Because do I have to move it if it's a cosine? No, because I don't have to move it because it's a cosine, because it's topping out at the y-axis. So therefore, I know I'm going to write it like this. Those are the 4 blanks you need to fill in. Here's a really cool thing. You guys just told me you wanted it cosine because we didn't have to move it left or right. So therefore, 0 can go where? Not the end. Where do I go left and right? With theta. In the parentheses. So you could write plus or minus 0 here because you're not going left or right. Eventually, in the long run, you wouldn't even draw that or write that down. Okay? Normally, that's not the first thing we fill in. The first thing we should fill in is our center line. What's the top point? Highest point? Where's the lowest point? So that means our center line is where? 0. Again, I'm going to put plus 0. Did I need to do that?
No.
No. In the long run, I wouldn't have to write that either. And then dividing by 2. We're taking the average, right? So now, now that we know our center line is at 0, we're topping out at 1. What's the amplitude? 1. We're not topping out at 1.
Half.
Oh, guys. I've been going too quick with you guys here. I'm not checking you guys. I'm taking you guys' word. The highest point is 0.5. Your lowest point is negative 0.5, which again goes to 0. So we are okay making that mistake. But notice that it was going as high as 0.5, as low as negative 0.5.
How do you know which one to do?
You have to go, your order should be center line, amplitude, and then the other 2.
I know. How do you know whether people are negative or positive?
You go by whatever the numbers are. Okay, so we know then that the amplitude, because the center line and the highest point or the lowest point is how far away? It's a 0.5 or 1/2. So that's why the amplitude is 1/2. Now, we need to do the period coefficient. So we know that normally, this is a cosine, it has a period of 2 pi. So I need to put it into that formula. So whatever I find by looking at this graph, it takes to repeat itself, I need to divide that into 2 pi to get a number. Okay, so I think it's the easiest thing to do is to start off at the top here because it looks like a good starting spot and go until I get there again. Down and up. I just did it.
Wow.
How far is that?
It looks like pi.
Well, we know it's got to be, we're assuming, I think maybe we can safely assume that it's a little over pi over 2. I wouldn't say it's halfway between pi over 2 and pi. Interesting. This one, hold on. This one, guys, I'm not going to say that it's halfway between pi over 2 and pi. So wait a minute. Didn't I say something earlier that when we had our coefficient be a 4, how many rotations or periods fit in the normal?
4.
4. Wait a minute. Does it go all the way to 2 pi in this one? It does. Can we trace that? How many?
3. Yeah.
1, 2, 3. What do you think our coefficient's going to be?
3.
3. Now, why? Why is it a 3? And because the reason why I didn't trust my numbers is because it didn't give me a good stopping point. Okay? I don't think any of these hills, this hill or this hill, gives me a good point here that I want to use. So I have to kind of revert back to how many did fit inside a normal 2 pi. Now, wait a minute. When it is 3, that means it's 2 pi over the period is equal to 3, right? That's what, because 3 is our coefficient. What would the period have to be, guys? What is the period actually? What is that first initial period right here? Solve for the period. Swap the places, right? Multiply by period, divide by. So the period actually is 2 pi over 3. It's 2/3 of pi. Can you guys kind of visualize that actually that kind of does look like about 2/3 of the way to pi? Okay? Now, I obviously wouldn't trust my estimating skills and say, oh, that looks like it's 2/3 of the way to pi. You kind of have to work with things and find your numbers. Now, guys, if this would have told me this, if it would have told me that's 2/3 pi right there, then I could have placed it into my formula here, and when I divided those two out, I would have ended up with 3. So you like it if it gives you a number that works out nice, and if not, count it up. Any questions? Okay, guys, your homework for tonight is a worksheet. Have a great day.